Okay, now we're on to the viscosity modifiers. And again, the Super X Gold ESP products use a very specialized viscosity modifier. So first, what is a viscosity modifier? They're actually polymers that we put in the oil to change the way the oil responds to changes in temperature and viscosity. Essentially, they improve the high temperature viscosity of the lubricant while still allowing for good pumpability at low temperature. There are three major chemistry types. The ethylene propylene, which we call olefin copolymers or OCPs, are, well, I mean, Infineum uses these, and they're what we call them. They're kind of cheap and dirty. They are effective. They do the job, and they are the least expensive type of viscosity modifiers. There are also polymethacrylates, which we do not use, and there are styrene isoprene, and that's the kind of chemistry that the Super X Gold ESP products use, and we call these star polymers. And if you look at the little kind of cartoon there, these products actually have a bonded center and then arms that extend out to increase the hydrodynamic volume of the polymer and make the oil appear to be thicker at higher temperatures. And you can see an olefin copolymer, an OCP, is kind of a long string polymer. And if you break it, then you end up with two short polymers, which are much less effective at showing a viscosity increase. But if you look at the architecture of the styrene isoprene molecule, you can see that if you kind of break off one of the arms, which does happen, you really haven't changed the basic architecture of the viscosity modifier, and it does a very, very good job of maintaining the desired viscosity in the finished oil. That's pretty much it for this slide, so let's go to the next one. As a measure of this, this performance, if you look at the blue bar on the right here, that is the requirement for to be able to license a CJ4 oil. The Kurt Orban is a diesel fuel injector, and it uses a tiny nozzle, and you put oil into this and you pump the oil through the diesel fuel injector, and passing through the injector will actually shear the viscosity modifier polymers. You can see the Super X Gold 1540 product at 90 cycles easily passes the 90 cycle requirement for stay-in grade for CJ4, and even when run 30% longer for 120 cycles, it still has exceptional shear stability, very good stay-in grade performance. So again, outstanding viscosity control with the viscosity modifiers that are used in the Super X Gold products. Next slide. On the other side of the viscosity modifier design criteria is low temperature pumpability. So we want the oil to have very good high temperature performance, which is maintained with the shear stability. But when the oil is cold, we also want to have very good flow properties. So these are actually samples taken from that same field test we talked about earlier, the Cummins ISX 450s, where we have performed the MRV as mini rotary viscometer temperature profile 1. This is one of the accepted tests to measure low temperature pumpability. And you can see 60,000 centipoise is the pass-fail limit for the fresh oil. So obviously all fresh oils must meet that. But what we've compared here is a Super X Gold with the styrene isoprene type viscosity modifier, taking drain samples at 10,000, 20,000, 30,000, and 40,000 miles. And you can see that certainly at 30,000 miles, we're still well below the fresh oil limit, while a conventional heavy-duty oil using an olefin copolymer type viscosity modifier, even by 10,000 miles, it has failed the fresh oil limit for TP1 MRV. Now, this doesn't mean that the oil has set up. It doesn't mean it won't pump. It just means that it doesn't pass the fresh oil criteria. That oil will still flow. It just does not flow anywhere near as well as it should. And even at 40,000 miles, although the Super X Gold ESP has failed the fresh oil limit, it is still showing much better flow performance than the corresponding OCP oil.